Oh, hello, welcome class. So today we're going to be dealing with basically inequalities with absolute value. So you should be able to know how to go through this one based off what we were looking at yesterday. So we have that positive 4. So if we subtract the 4, what happens? We're going to get that negative 4 on both sides. Subtract the 4, subtract the 9. That's just going to get us a negative 13. So right here, I saw this happen several times yesterday. They said, okay, well, I can make this 13, and x is 13, x is negative 13. Absolute value cannot be negative. It's a distance. Distance cannot be negative. So in this case, we have no solution. All right. So from here, we are going to be calling inequalities. As you see, day 2, I call you inequalities. So that's going to be the main focus for today. All right. Mind the people out in the hall. So we have the warm up, having a discussion, classwork, conclusion. So the next few slides, graphing absolute inequalities only results in 2 graphs types, just samples. So we're not seeing any equation. What do you notice? Well, if you're looking at they're either both going away or they're both going towards. But the one thing you should be paying attention to is the end point. They are the same on this one, and they're the same on this one. I could have made one of these two open, but you'll see that with the graph, with the absolute value, the endpoints should be the same. They're either both included, which would be the open circle, or sorry, filled circle, or they're excluded, which is the open one. All right, so let's have a look at it. We're going to solve this traditionally. We have 3x minus 6 on the inside, and we have it being greater than 9. All right, so since we don't have to do any forced simplification, we can just bring that right on down. Now, we could divide by 3, 1, 2, 3 terms, or we can just move the 6 over. It's probably best to move the 6 over, that way we have to multiply and divide less terms, so let's just go do that. We're going to add 6 to both sides. All right, by doing that, we can cancel, and 9 plus 6, we reduce to 15. Now we're going to divide by that 3. And we're going to be able to cancel and reduce. 15 divided by 3 gets us 5. So now we have to flip that inequality when we look at the negative value. Okay. So what we're going to do now is, again, add the 6. So follow the same step here to both sides. So we have 3x is less than or equal to negative 9 plus 6. Well, we can simplify that side and get a negative 3. Divide both sides by 3. And we'll get x is smaller or equal to negative 1. All right. From here, we have both our solutions. So let's go ahead and work with that a little bit. So now it's time for the inequality. So notice we have 2 different solutions. We can have a check here pretty soon. And we have the starting at 1, or sorry, 5. And we want to go that way. And negative 1 wants to go that way. So notice that when this term is bigger, it looks like it's going away. Let's go have a look at that. Okay. And if you're not entirely sold on that, let's go ahead and plug in a value. Say, how about negative 2? We're going to take that negative 2 and plug it right on in. 3 times negative 2 is going to get us negative 6 subtracts negative 6. The absolute value of negative 12 is 12, and 12 is bigger than 9. So you see it works on this side. Okay. What about this side? Well, we're going to bring in that 0. 3 times 0, well, that's going to get us a 0, so it's the absolute value of negative 6. And we're trying to say 6 is bigger or equal to 9. And that's not true. So you can see that when we have it facing this side, the absolute value is bigger than something, we're always going to have the OR situation prop up. So that should be a good indicator of what to do with that, okay? So go ahead and give that a thought, go from there. So Notice that this one is saying 20 is bigger than whatever's going to be in here. So let's take a second to think about what's going to happen. Since this is positive, we're going to have two solutions for x that we can get from here. All right. But this absolute value always turn whatever we put into here at the very end positive, right? Because of that, that really limits us to how large of a number for x we can put in. For instance, we can't put in, say, 100, because 4 times 100 is going to get us 400 minus 12 is still going to be much larger than 20. All right, so let's go ahead and work through this a little bit and find what the actual x term will be. So we can divide by 4, but that will be divided in 3 terms. So let's just bring it down to 2 terms by adding 12 to both sides. Okay, so now we can see that we can just cancel right here. And then we're going to reduce 20 plus 12, 32. And we're going to divide everything by 4. By doing that, cancels over here. 32 and 4, well, that's divisible. And you should be saying 8. So now we have to flip the inequality, as you see here, facing the opposite way, and going from there. We're going to be adding the 12 to both sides. 4x minus 20 plus 12. 4x is bigger than negative 8. Divide by that 4. Since we're dividing by a positive 4, we don't have to flip this again. Divide by a positive, don't have to flip. Cancels over here. 8 divided by 4 is just going to get us a negative 2. So we got our two solutions. X has to be smaller than 8, but x has to be bigger than negative 2. So let's go ahead and work on graphing that. For negative 2, we come on over here, and the arrow looks like it's pointing towards this way. For the 8, we come over here, and the arrow is pointing towards negative infinity. So this, you can see, is an and situation. All right? So whenever, does this support your theory? That whenever you have this number being bigger than this, you're going to be in an and. If this number is bigger than this, you're going to have basically, sorry about that, an or. Some loud kids are in the hall, the little ones. Anyways, so let's go have a look at this. For example 3. Notice we have to do some work first. We have this plus 3, so it's not isolated, not by itself. So what do we need to do? We need to take care of this. So we're going to add that 3 to both sides. By doing that, we can simply cancel on the one side and simplify. Now, what are we going to do here? Well, we're done, so we can just pull that out and start to work with it. X minus 2 is bigger than 8, so we're going to add 2 to both sides. By adding 2 to both sides, we get x is bigger than 8 plus 2, which is 10. X minus 2, flip the inequality, negative 8. Add 2 to both sides. X is smaller than negative 8 plus 2, which is negative 6. All right, so let's go ahead and graph that. Since we have that 10, we had to bring in a different number line, so I had to find a different one. Now I have found a way to generate them, but that's why this looks slightly different. We need to find 10 way over there, and this one wants to go off in that direction. We need to find 6, go over there, and notice that it's the same kind of open circle. And this one wants to go off in that direction. So the arrow pointing this way, the arrow pointing this way. So fill it in, good to go. So negative 7 will work, 11 will work, etc. All right. Pretty straightforward, pretty easy to follow. Example 4. Notice that this one has a decimal. That's the reason I chose this one, because this one has a decimal. Well, I made one that had a decimal at least. All right, so we can't have ones that have decimals. Notice this one's pretty simple. All we need to do is one thing. There's an x inside the absolute value, so we want to isolate the absolute value, but right now we're adding 2.4. So we need to take care of the addition of 2.4 by subtraction. Okay, so we subtract the 2.4 from both sides. And when we do that, we get 1.2. So we can write that as x is less than 1.2 and x is greater than negative 1.2. So let's go ahead and graph that. So 1.2 is right about there, pretty close to the 1, pretty close to the negative 1, and they want to go towards each other because this one is saying this one over here wants to go this way. This one is saying this one over here wants to go this way, so they smash together. All right. So here's a bit of more of a tricky one. Notice we don't have to do anything on the inside, or it's not the inside, sorry. It's the outside. It's already isolated, so we can write exactly as is. But for this one, let's just go ahead and try that simultaneous solve, all right? So looking through here, we have several different things we can do. We could subtract the 2/3 from both sides, but then this would turn that 4 into a fraction. Because what we're going to do one side, we're just going to do it over here as well. Or we can focus on this 3 and say, hey, I don't want to deal with a fraction right now, and the only fraction I see is this denominator of 3. So if I multiply every single term by 3, that'll take care of it. Let's go ahead and do that. So we're going to multiply this by 3 and this whole thing by 3. Okay? So you'll see that even though it looks complicated right now, it's going to get really quick, really clean, really easily. So we're just going to distribute that 3 through and do the same over there. And all we really need to do is solve if this was a different number of what this was. Or solve because, not a different number. Sorry. You can see that 3 times 2, that's still going to be 6. 3 divided by 3 is still going to be 1 times 2. And 3 times negative 4, or positive 4, is still 12. So we have that 6. This is a bit longer, so we're going to continue on this. So we're just multiplying the first one. So we have 6x plus 3 divided by 3 times 2/3 is strictly less than or greater than 3 times 4 or 3 times negative 4, respectively. So let's go ahead and bring that up and have a look at this next one and continue. So next we're going to cancel right here, 3, 3. So that's just going to get us a 2, because 3 divided by 3 is 1, times 2 is 2. 3 times 2 is 6. 6 divided by 3 is still 2. So the last thing we need to do is 3 times 4. Well, that's 12, so we have 12 on that side and negative 12 on the other. Now we're at the stage where we can just simplify and solve. So we're going to subtract the 2 from everything. And if you're saying this is already starting to look like a fraction, at least on one of them, well, you would be right. So if 6x is bigger than 12 minus 2, and 6x is also less than negative 12 minus 2. 6x is bigger than 10. 6x is less than negative 14. So now we're just going to divide that through by that 6. All right. Leaving us 10 and 6, and we can reduce these two, and 14, negative 14, 6. 10's even, 6 is even, so let's just take out that 2 and leave ourselves with a 5/3. 14 is also even, so we're going to end with the thirds above, down below again, but it's going to be 7. All we did was break off the 2. 10 divided by 2 is 5, 6 divided by 2 is 3, 14 divided by 2 is 7, 6 divided by 2 is 3. All right, so now we have this as our solution. We have to graph this. So 5/3 is, well, thirds, 5 divided by 3 is 1 and basically 2/3, so we can put that approximately right there. Negative 7/3, well, that's going to give us just beyond 2. Negative 2, that is. All right. Which way are these going? Well, 5/3 wants to head off this way. Negative 7/3 wants to head off this way. So this one wants to go off towards negative infinity. This one wants to go off towards positive infinity. And look, we are done. Have a nice one.